Deep within the Earth's crust, a cataclysmic force lies dormant supervolcanoes. These geological behemoths possess the power to unleash eruptions dwarfing any witnessed in human history. Unlike their smaller counterparts, supervolcanoes do not possess towering peaks. Instead, they lurk beneath vast calderas, often hidden in plain sight. These sleeping giants, capable of ejecting thousands of cubic kilometers of ash and rock, pose a significant threat to our planet and its inhabitants. The recent eruption of Hunga Tonga Hunga Ha'apai, while destructive, pales in comparison to the potential fury of a supervolcano. Scientists estimate that a full-blown super-eruption could be 10 to 100 times larger than the Tonga event. Such an eruption would have devastating global consequences, impacting climate, agriculture, and human civilization itself. The threat is not merely hypothetical. Geological records bear witness to the devastating power of super-eruptions. The eruption of Indonesia's Mount Tambora in 1815, a cataclysm far smaller than a full-scale super-eruption, serves as a chilling reminder of the potential for devastation. Even more concerning is the knowledge that a super-eruption is not a matter of if, but when. Understanding the mechanics of these slumbering giants is paramount to comprehending the gravity of the threat they pose. Their eruptions are not mere explosions of molten rock, they are events capable of reshaping the planet itself. The urgency to prepare for such an event cannot be overstated. Deep within the Earth's crust, a cataclysmic force lies dormant supervolcanoes. These geological behemoths can unleash eruptions dwarfing any in human history. Unlike smaller volcanoes, supervolcanoes lurk beneath vast calderas hidden in plain sight. Capable of ejecting thousands of cubic kilometers of ash and rock, they pose a significant threat. The recent Hunga Tonga Hunga Ha'apai eruption pales in comparison to a supervolcano. Scientists estimate a super-eruption could be 10 to 100 times larger. Such an eruption would have devastating global consequences, impacting climate and agriculture. Geological records bear witness to the devastating power of super-eruptions. The eruption of Mount Tambora in 1815 serves as a chilling reminder of potential devastation. A super-eruption is not a matter of if, but when. Understanding these slumbering giants is paramount to comprehending the gravity of the threat. Their eruptions can reshape the planet itself. The urgency to prepare for such an event cannot be overstated. In 1815, Mount Tambora erupted on Sumbawa, Indonesia. It ejected 160 cubic kilometers of material, causing a global volcanic winter. The following year was known as the year without a summer. Crop failures and famine led to social unrest. In January 2022, Hunga Tonga Hunga Ha'apai erupted. It was the most powerful eruption in recent history. Tsunamis reached Japan and North America. These events show the world is unprepared for a super-eruption. Despite the existential threat posed by supervolcanoes, global preparedness for such an event remains woefully inadequate. While billions are poured into planetary defense against asteroid impacts, a statistically more likely threat receives a fraction of the attention and resources. This disparity in preparedness represents a glaring blind spot in our approach to global risks. The reasons for this lack of preparedness are multifaceted. One contributing factor is the infrequency of super-eruptions. With the last known event occurring tens of thousands of years ago, a sense of complacency pervades. However, geological time operates on vastly different scales than human lifespans, and the absence of recent super-eruptions does not diminish the very real threat they pose. Another challenge lies in the sheer complexity of predicting and mitigating the consequences of a super-eruption. The cascading effects on climate, agriculture, transportation, and global supply chains would be unprecedented, demanding a coordinated global response that currently does not exist. The lack of a unified international response framework further exacerbates the problem. Unlike asteroid impacts, which are often perceived as a threat to humanity as a whole, volcanic eruptions are typically viewed as regional disasters. This perception hampers international cooperation and resource allocation, leaving the world ill-equipped to confront the global repercussions of a super-eruption. As the planet grapples with the escalating consequences of climate change, a troubling synergy emerges. A warming world may amplify the devastating effects of a supervolcanic eruption. The intricate interplay between these two powerful forces could exacerbate the already dire consequences of such an event. One of the most significant ways climate change could worsen a supereruption's impact is through its influence on atmospheric circulation patterns. The massive injection of aerosols and greenhouse gases from a supereruption would interact with an already altered atmosphere, potentially leading to more extreme and unpredictable climate disruptions. Furthermore, climate change is causing rapid melting of glaciers and ice sheets, particularly in regions prone to volcanic activity. This melting can trigger a chain reaction, reducing pressure on underlying magma chambers and increasing the likelihood of eruptions. The added stress on volcanic systems from glacial melt could potentially hasten the timeline of a super-eruption. The warming of the oceans also plays a role. As ocean temperatures rise, they expand, leading to sea level rise. This, in turn, puts additional pressure on coastal volcanic systems, potentially increasing their instability and the likelihood of eruptions. The complex interplay between climate change and volcanic activity underscores the urgent need to address both crises in tandem. A super-eruption would unleash a cocktail of gases and particles into the atmosphere, with sulfur dioxide playing a particularly significant role in the ensuing climate chaos. This gas, once aloft, undergoes chemical reactions to form sulfate aerosols, microscopic particles that linger in the stratosphere, high above the Earth's surface. These sulfate aerosols act like tiny mirrors, reflecting sunlight back into space and reducing the amount of solar radiation reaching the planet's surface. And this phenomenon, known as global dimming, leads to a cooling effect that can persist for years or even decades following an eruption. While volcanic cooling might seem like a counterbalance to global warming, the reality is far more complex and potentially dangerous. The sudden and dramatic shift in global temperatures would disrupt established weather patterns, leading to unpredictable and extreme weather events worldwide. Regions accustomed to specific climatic conditions could experience drastic changes, wreaking havoc on agriculture, water resources, and ecosystems. The impact of sulfate aerosols extends beyond temperature. These particles can also damage the ozone layer, which protects life on Earth from harmful ultraviolet radiation. The depletion of the ozone layer could increase the incidence of skin cancer, cataracts, and other health problems, particularly in regions already vulnerable to high UV levels. Section 6. A chain reaction: how climate change fuels volcanic unrest. The relationship between climate change and volcanic activity is not one-sided. While a super-eruption can trigger dramatic climate shifts, climate change itself can increase the likelihood of volcanic unrest. This unsettling feedback loop underscores the interconnectedness of Earth's systems and the potential for cascading consequences. One of the primary ways climate change influences volcanic activity is through the melting of glaciers and ice sheets. The weight of these massive ice formations exerts significant pressure on the Earth's crust. As glaciers melt, the pressure lessens, allowing magma to rise more easily towards the surface. This phenomenon, known as isostatic rebound, can destabilize volcanic systems, increasing the likelihood of eruptions. Increased rainfall, another consequence of climate change, can also influence volcanic activity. Heavy rainfall can seep into the ground, interacting with magma chambers and generating steam. This buildup of pressure can trigger steam-driven explosions, known as phreatic eruptions, which can precede larger, more explosive events. The link between climate change and volcanic activity is particularly concerning in regions experiencing rapid glacial retreat, such as Iceland and parts of South America. These areas, already volcanically active, could see an increase in the frequency and intensity of eruptions as the effects of climate change intensify. Section 7. Global hotspots: identifying the most vulnerable regions. Certain regions are particularly vulnerable to supervolcanoes. Identifying these hotspots is crucial for global preparedness. Regions near supervolcanoes face severe threats. Yellowstone in the US, Campi Flegrei in Italy, and Toba in Indonesia are key examples. An eruption would devastate millions nearby. Section 8. Facing the inevitable. The urgent need for action. The threat posed by supervolcanoes is real and potentially catastrophic. While we cannot prevent these geological behemoths from erupting, we can take steps to mitigate the risks and improve our preparedness for the inevitable. A crucial first step is to expand scientific monitoring and research efforts. By closely monitoring volcanic activities, studying past eruptions, and developing advanced forecasting models, we can gain a better understanding of the triggers, timelines, and potential impacts of super eruptions. This knowledge is essential for developing effective early warning systems and evacuation plans. Equally important is the development of a coordinated global response framework. A super eruption would be a global catastrophe, demanding international cooperation and resource sharing on an unprecedented scale. Establishing clear lines of communication, coordinating relief efforts, and ensuring the equitable distribution of essential resources are critical components of a successful global response. Public awareness and education are also paramount. By educating the public about the risks of super eruptions, promoting preparedness measures, and fostering a culture of resilience, we can empower communities to better cope with the aftermath of a disaster. Section 9. Conclusion. A call for vigilance and preparedness. The Earth, for all its beauty and bounty, is a volatile planet. Deep within its fiery heart lie forces capable of shaping continents and altering the course of life itself. Supervolcanoes, with their slumbering power and potential for global devastation, stand as stark reminders of our planet's awesome and sometimes terrifying might. We cannot, nor should we, live in fear of these geological giants. However, we must acknowledge the very real threat they pose and take proactive steps to prepare for the inevitable. By embracing scientific inquiry, fostering international collaboration, and empowering communities with knowledge and resources, we can face the future with vigilance and resilience. The time for complacency is over. The Earth has spoken throughout history, its voice a symphony of creation and destruction. It is our duty to listen, to learn, and to prepare for the day when the sleeping giants awaken once more.